Good morning or afternoon, everyone. Uh, my name is Carl Dessence,
And I am Columbus Cali.
and we're going to get started here. Um, Basically, what we're going to talk about today is liftgate charging, the diagnostics, as well as some PM checks that you can make to make sure the system is operating correctly as you go. Uh, One thing to note, test lights don't work anymore, especially when you're checking our charging system. When you call into tech support, which I'm one of the people you probably would talk to, we need specific values, and that's where a multimeter comes in. At the same time, as being a technician, I've done it myself. We have a tendency to probe the wires. We don't realize we break strands in there, and then we have basically a four-lane highway down to 2 lanes. So we restrict how much we can get through, and that creates problems in our electrical system, both on the trailer as well as liftgate charging. So get used to a multimeter, if nothing else. When we look at this, we have several different type of nose boxes, and the nose box actually is what controls the charging system. But you can see up there on the upper right, you see the old Select, which is the black box, and then the newer updated box, which is the white one, the direct box, which is 2, and then below you see the Plus, the Flex, the Max. These are our new nose boxes that have a faceplate with them. I do know some of the customers also run a Select box that has the single and dual pole tied to that faceplate as well, as same with the direct. So there are many options there, but the thing to remember, that is just a control. My liftgate charging is the same for all of them. Technical difficulty there. Okay, so one of the big things we see is no lights on the front of the controller. And in this case, when you don't have the lights, more than likely you're not charging the liftgate battery. So one of the first things we always go to is there's a 2 amp fuse on that charge plate, and you see it here, it's highlighted. A lot of them were black in color. Some of them today are coming out, they're actual orange, and they'll match up to your small orange wire that goes into the front of the box. In this case, check it. We want to make sure it's a 2 amp fuse. If you put higher than that in there, you can end up burning up the front box. This is protection for the electronics that are in the front box there. Another thing we have seen is the 30 amp ground fuse in the back of the box, the faceplate. What you usually end up doing is we take and throw our own meter on it with all the wires connected. It shows good. Well, the reason it shows good is because it's getting a ground through the trailer body. Remove that top wire off of there, which is going to the liftgate charging system, and then check it. If you do happen to put your meter leads on there without removing that wire, you see more than 100 ohms, that fuse is blown. It's blowing itself just outside of that window, so you can look at the window and the fuse looks good. That is another thing. It's a whole lot easier to change that fuse than have to change the faceplate. That's the way we look at that.
Absolutely.
The next thing to look at, though, is your lights on that nose box always dictate where your issue may be. So that's a good thing to look at, to check with. I know we have links tied to the webinar that take you to the different lights, and you see some of the pages here, but I ask that you go through those especially. So when I start looking at my wire ends, one, we got to make sure they're the correct size. Correct size meaning the eyelet is the right size. It's not too big. As you look at this picture, you can see the eyelet on that white or the yellow wire there is quite a bit larger than the stud. At the same time, it's also larger than the wire. So it's probably made for about a 10 gauge wire, and you're only looking at a 16 to 18 gauge there. So you got to make sure we're matched for that, because that will create a heat resistance, maybe a hot spot. And anytime I have warm, wire or connections getting warm, there's more resistance there. Once again, I can't get current flow out there that I should be to the components. The other thing, make sure you don't over tighten your terminals. There are torques on all of these, and it is in all our documentation. So let's look at some of the things we absolutely have to have and know. One, we have inputs, okay, to the faceplate. Blue and white wire coming from my source, be it the truck, be it the 7-way from the truck, be it a dual pole, single pole cable. I always have to have that. It's got to be 13.2 volts for 5 minutes or 13.8 volts and above immediately. And at that point, it's telling the smarts inside that faceplate that, hey, I need to start putting an output voltage. But the other thing I need is the orange wire. I need to see liftgate battery voltage, and that has to be above 7 volts. If it's not above 7 volts, you may not see any lights on there. So those are inputs to that faceplate. Then the outputs I have, the black wire, which goes to the input on the charge plate, the white, because we're going to ground our system as well separately, and then the yellow. And the yellow is what tells our DC-DC converter, let's go ahead and start charging. The voltage on that yellow wire should at least be 10 volts. So we're going to have, we know that we've got input. Your black and white should be similar to what you're seeing on your input on the blue and white. So if I see 13.2, I should be within a volt or so of that 13.2 coming in down here. And usually it'll be less than that. We've got 2 different converters that you're going to see out there. One is this 4-pin module that we changed right around 2021. We went to the updated one, but it has basically one LED indicator, and I'm either going to see a red, green, kind of alternate between them. It'll be basically the system is off. Solid green means I'm charging, and then if it's a red, green flashing, that means I've got a fault in there, be it over temperature, any of those things. Now, the one thing we always have to look at, though, is our connection points. This is our Astra that we've been putting in all our systems since 2021. It still has one light, but I have a little bit more different colors associated with that. So a flashing green says everything's ready to start. I've got good input voltage. I just don't have anything on my ignition telling me to start charging. Okay, so I will not see the output going to my liftgate battery going up. Solid green tells me I'm charging, so I will see, say I've got a 12.9 volt coming in. I'm going to see above 12.9, probably 13 or higher, hopefully a lot higher, coming out on that red wire. All of this system, as well as the others, are all regulated, and you will see the voltage and amperage change based off the outside temperature. So if it's colder, I'm going to have a higher voltage, higher amperage to recharge my batteries. Where warmer, I don't have to have as much. So just to give you an idea on those. So we got our first poll questions. So we're going to ask you then, it says, how many amps should that small mini fuse be rated at? And this is the one back there on the charge plate. So if you guys will throw an answer there, we're going to wait a little bit, see what we have, and be able to give you an idea here. Wait a little bit longer. We're all good. All right, we're almost to the point. We've got a good portion of you guys making that. So let's look here. So what are we rated at? Looks like we've got the answer is 5. I'm looking at my screen. It's not popping up here, guys. Sorry. 5 is not it. 2 amps is the correct answer. So as we go through, just know you may see a 5 amp in there. You never go above that. We want to keep it at 2. Like we said, that will affect the electronics. Now, once we know that we have some lights going on, we want to do a quick operations check. This also goes along with your PM. One of the things, obviously, we love to have a truck. We know that that's not always available, but we like that. Our system, if it's got a dual pole, it's always going to look for that for the power source first, since we know that goes directly back to the batteries for the vehicle. If you are using a light tester or a battery, make sure that you have a fast charger on that. And by fast charger, I mean automatic chargers usually do not put out the amperage we need right away, because once the system starts charging, I could see 25 amps really quick. And then that automatic charger doesn't compensate quick enough, and we get what we call the railroad lights. So want to make sure where we're at. Now I have a quick video here of showing you what the railroad lights are. You're going to hear a little bit of voices in the back. Please, don't pay attention to those. There's nothing going on there that can help us here. So let's look, and here we go. See, we've got solid green lights right away. That tells us we're above 13.2. At that point, we started charging. Now we went to the flashing orange, which went below. And then once it sees the good input voltage again, the 13.2, that light's going to turn back green again. So those are the things to look at. I could tell you. There he goes for the next one. I could tell you that for about 40% of our calls lately have been all tied to just that, with the lights being flashing red and green. All right. So here's the next thing. What's the minimum voltage that you must go to the nose box for it to power up? We've got four questions there. 4 answers. Let's give you some time to know.
And while you guys are submitting your answers, a little bit of just food for thought when you run into those railroad lights like that. Typically what's happening is our system is seeing that it's got a sufficient amount of power to start pushing back to those batteries to get that converter to kick on. And as Carl was saying, once that converter kicks on, you could expect, a pretty high current draw from that converter, upwards to about 25 amps. And what happens is that once it kicks that converter on, it's dropping that voltage, that input voltage, either too fast or too low. And our system sees that as a fail-safe, and it's going to shut itself down as to not compromise anything on the tractor, whether it be the 7-way primarily. But we would much rather see our system shut off or rather than continue to pull down and drain your truck batteries. It's a lot easier to get a gate up than it is to get a truck up.
As I say, at the same time, usually when we see those lights, the problem is ahead of our system. So that may be your dual pole socket, it may be your 7-way socket, it may be the truck that you have connected to, or the supply. So just some things to remember here.
Absolutely.
And we have that. All right. Good job, guys. 13.2 is that correct answer. We have to be above that for that minimum to get that system to start charging. All right, we're going to let Columbus take on some of this preventive maintenance here.
All right, thank you, Carl. And once again, my name is Columbus Calley. I handle a lot here with Purkeys, and we're going to dig right into this. So, starting off with preventative maintenance, this is your backbone in preventing future incidents from happening for the most part. So, when we start talking preventative maintenance on our liftgate charging systems, there's a few key points that we're going to try to make sure that is included in every single one of our PMs. And it doesn't have to be very, very long, but you at least want to pay attention to it. So starting off with this main harness. So that main harness is going to be your 4-conductor harness that is going to connect that front Purkeys nose box, and it'll run the duration of the trailer back to the liftgate battery box. And what we're looking for is any kind of rubs. If this trailer was, damaged previously, or for some reason those harnesses had dropped and gotten caught, with the fifth wheel, we want to look for, different splice spots or bare spots within the insulation. We want to make sure that if anything was altered on this harness, that it was, taken care of properly. And what by that I mean, it's replaced with, right size eyelets, as well as heat shrink and solder if you have the capabilities of doing that. These are some really easy things that can save you a lot of money and a lot of headaches and downtime while these trailers are on the road. Now, we're going to take a quick hop back to the liftgate battery box, and we're going to talk about our charging plate assembly, or the P1020K, should you ever have to get in contact with us as far as troubleshooting. Now, one of the biggest things that you'll see, whether it's new techs coming into the field trying to work on these, or if it hits a third-party repair facility, is over-tightening some of these terminals. We don't recommend ever using power tools on, either taking them off or tightening them, just because, if one of these gets stripped, now we're creating more work for ourselves to get it all put back together properly. And what can also happen is, if you notice in this picture to your right there, is you've got these red junction studs. Those, I've seen those snap in the past. I've seen them break that molding and start spinning. And then now you've just got primarily a bolt that's floating around your battery box, and every time you hit a bump, you've got a small fireworks show going on. So just pay attention when you're doing your PMs, and look for some of these things. And you also want to take another quick look and make sure that on these terminals that are connected to either your bus bar or your junction studs, that the insulation or the heat shrink that's slid over these terminals is not pushed too far forward. This is another thing that can cause a lot of resistance buildup, and could inevitably, cause your system to not charge properly. And it could definitely give you some funky readings should you not catch it right away. All right, so as we were saying before, inspect your terminals, make sure that everything is tightened down nicely. Typically, when you're looking in this battery box and you're wondering what to grab out of your toolbox, you're only going to need a 3/8 socket and a 9/16. Just that's all you got. So after we've done all that, you can always think to look for any kind of exposed copper, with this being on the underside of the trailer. Though a lot of these manufacturers make their battery boxes very well, there's always potential for water intrusion. And if water gets in on there and you happen to have a small cut into that copper on that wire, that's where corrosion starts to build up. And in our industry, when you're doing PMs and you find green on copper, that doesn't mean money. Well, it does in a way, but it's not in the good way. So again, if you see something like that, it's best to go ahead and try to repair it quickly versus, just throwing a Band-Aid on it and getting it outbound. Now, Carl touched on this briefly before, but we've got our 30 amp breaker that's going to be mounted on a little aluminum L bracket that's usually mounted to to the roof of that battery box. We're just doing quick views, making sure that the breaker itself is not tripped. And as an extra precaution, what I like to do is I like to go through and double check my voltages on it. So on the back side, I know you can't see from the picture here, but on the back side, you've got two threaded bolts that's on the back there, and that's going to be for both of your output wires. I like to go through with my multimeter and check voltages on both of those studs, just to ensure that I'm not seeing any kind of differentiating values on my voltage readings. And then, of course, we're always looking to make sure that everything is secured properly, making sure that, again, your terminals are tightened nicely. You don't have to test your strength on it. Snug is good, especially with the nylocks that we use on these studs here. Now, here's where we see a lot of common issues, and this is with the 4-pin harness that plugs into these Eaton style converters. This is something that we have worked around with, for years, trying to figure out what's going to be the best, and how can we make this as easy to troubleshoot and test in the field for not only your shop technicians, but any other third party as well. So when we are trying to inspect this, what we want to do is first disconnect that 4-pin harness from the converter itself. And then when you flip it out, what you're going to end up seeing is this little plastic insert. Now, this is not the ideal scenario of what you want to see when you disconnect that, obviously, but you have a plastic insert here that correlates with the 4-conductor harness as well. And what we've got here is red's going to be your output, black obviously is your power input, yellow being your ignition, or as I like to say, that is the keys to turning on this converter, as well as your ground. Now, what you see in this picture here on the right is a quote-unquote thermal event, and this is due to a high buildup of resistance. That's usually due to a improper crimp or a loose connection on one of those pins. So if you suspect that something may be loose or that you're generating a lot of heat and you haven't reached this point yet, it's always good to pull out that orange plastic insert and make sure that all your pins are locked in. Once you've verified that, go ahead and reinsert that plastic insert and plug it back in and see how your results fare from there. And again, this is kind of going to show that the male Deutsch connector or Deutsch pins that's within this connector all correlate with the right connector that we're providing with these. Now, when you look at this battery box here, we've got a lot going on. And unfortunately, it's a lot of not good stuff going on. So we've got a lot of issues that we need to address with this. So when you are doing your PMs on your battery boxes, we need to first make sure that there is nothing floating around. Because if any of those components start to arc, whether it be the circuit breakers or, oops, we swapped batteries, forgot to connect this up, now we're looking at our system not going to charge, or it could provide intermittent charging because it's not getting the proper connections. So what we want to keep an eye out for is, again, making sure everything is fastened properly, make sure all your connections are tight, make sure that your battery hold downs are not just there for show. Make sure that they are tightened down as well. Because again, we don't want these things sliding around. These trailers are on the road and picking up every little bump and crack in all kinds of conditions. And then we want to make sure that if we see any kind of buildup of corrosion or anything on the tops of these studs, that we are addressing that as well.
Now, the one thing to note here is off the white stud on our charge plate, that the ground, you should have that cable going to one ground cable, and then the one that the red wire connects to that goes through our circuit breaker should be on a positive post on the opposite battery. That way you're using both batteries. You're not just charging one and draining the other.
Right. And it also, you know, it really helps with the charge profile as well. But because if you think about it, if you have them both connect up to the same battery, that's just the waterfall effect. So you're filling up one and letting it spill over into the other, and they're never going to be hitting
Balance.
that equilibrium.
Yep.
All right. So leads us to our next poll question. So should the positive cable or positive and negative wires from the Purkeys charging plate be on opposite batteries in the battery box? I'm going to give you guys a little bit to get this one, and then we will start to move on.
Yeah, and this definitely is important for system operation as well as maintenance.
Absolutely. All righty. Let's see what we got here. Okay. So yes is the primary winner on this one. So as we stated before, and as Carl mentioned, we definitely want to charge these batteries evenly. It's not only going to, you know, prevent faster wear on the batteries, but it's actually going to prolong the life of them, as well as one of them's not having to compete with the other to balance out that charge. And like I was saying before, when we're doing our battery box inspections, we have to make sure that we are looking for these loose nuts, making sure that, you know, they're all tightened down properly. Looks like we do have torque specs on these as well. I think it's, what is that, Carl?
It's between 11 and 13 foot-pounds, so about 10 foot-pounds. It's not very tight, and you definitely don't want to use an impact on, because what happens is you strip the stud out, and not only do you strip it with the nut, but you strip it out in that lead pad. And at that point, you just about ruin the battery. You definitely shorten the life, because you're not going to get the output that you should from it, as far as the amperage output, the voltage output, any of that. So it's important to make sure we don't over tighten those.
All right. And then, as I was mentioning before about corrosion, now corrosion's a big killer in the battery industry. And if you can stay on top of it, you know, whether you're using sprays or, you know, dielectric grease or something, don't go crazy with it, but it definitely helps. And addressing it early on can really save you from being put in a pinch later on down the road. Now, some locations may not see this as much as others, but I still firmly believe that the same practices should be, you know, taken regardless of where you're at. Now, this is kind of going through and making sure that, you know, your batteries are linked properly, but they're also tightened properly as well. And this is a big thing that we have to stress on, because though you may have this trailer one day, you know, 50,000 miles down the road, it may end up at another location or sitting in a lot or at a third party. And at that point, time has gone by and there's no telling how many hands have been in there. So making sure that you've got a good PM plan and checking for some of these things is definitely going to help you out. Now, when it comes down to battery hold downs, you know, again, you know, they're there for a reason. You know, we might as well use them. So this is one of those things that these batteries aren't made out of steel. You know, don't try to tighten it down as tight as you can. You want them nice and snug. You don't want to put any extra stress on these batteries than you absolutely have to, but you also don't want them sliding all over your battery box when that trailer takes a turn or hits a pothole.
And the other side of that is with your battery hold downs, if those batteries are able to basically move around and jostle around, you're shortening the life of it. Because when I'm dealing with a lead acid, then I have a tendency, and even with some of the gel, I can use some of that lead off of those plates inside each cell. May not see as much with an AGM, but I'm shortening the life of it. That's the other reason you want to keep your hold downs tight and in place.
That's a good point. All right. So next poll question. How often should all connections be checked in the battery box? This is a big one because I know that everybody does things a little bit different. And we're all just kind of curious to see what your use case scenario is and how often you are PM in the battery box on your trailers.
Okay, we're getting some results here. And these are all just nothing more than good reminders on maintenance. And for some of you, you don't have a big say in the maintenance that's done, but it helps us to remember these things.
Absolutely. All right, guys, let's see what we got here. So all of the above. I think that's pretty good. I'm a little different. I like, because I've done this for so long, just out of habit, I like to check every trailer I run into. But I understand that that's a lot of time. But I think that you guys are doing really well with how things have been going. All right. Any questions? Seems to have concluded our webinar for the day, but we definitely want to make sure that if you have questions, we are there to answer them. And if you don't have any at the moment, feel free to reach out to us. You know, both Carl and myself are always here to help, as well as the rest of our guys here at Purkeys.
And I think one thing that we failed to mention as I'm looking at notes here, your battery, from the battery to the pump motor, the ground, is very important, as well as pump motor to trailer body. Those will affect our system, and usually when we see the ground fuse blown, that also creates the problem of bad connections. Okay, it may be in the cable, it may be to the body, but usually there's an issue there, and that's one thing to look at. It'll help you save some time in basically operation. And as we know, time is money, and everybody likes to keep their equipment moving and loads being moved. So guys, we want to thank you for your time, but if you'll hang on just a little bit as we're getting ready to wrap up this webinar, you're going to see there is a brief questionnaire that's going to pop up on your screen. If you will, please answer that. Take the time and answer that. Not only does it give us feedback on how we did as far as the webinar goes, but also ask you about future webinars or things you'd like to hear about. So at this point, we are going to wrap it up, and we want to say thank you for your time. And if you have questions, feel free. You can contact us either by email or by phone. The phone number here at Purkeys is area code 479-419-4800. And right now, we'd like to thank you for your time, guys, and you have a great day.
Absolutely. Thank y'all.